Hello friends, I welcome you all to this session on numerical methods in C++. So today we will be writing code for bisection method. Last lecture I have already discussed with you about bisection method. So let us take one problem. Let's say I am interested in finding out the roots of this equation. Let's say 5x plus 4. Now you know that this particular is polynomial is basically a quadratic equation, and it will be intersecting at 2 points, that is 1 and this will be 4. Now what we'll do is we will take one bracket. Let's say I'm going from -2 to 2 and see where that root is. Now the first step to program it is first you find out, first you should have one function. Okay, you will be writing one function, this one. Then in the second step you should have the bracket, that is a, so which is right now -2, and the b, which is 2. Okay, once you have the bracket, then you should check that whether that particular bracket have any root or not, and this you can know by finding out the value of the function for both the extremes and then multiplying them. And if this multiplication comes out to be negative, that means root is there in the bracket. And if it is false, then you have to stop by saying that the root does not exist in this particular bracket. Otherwise, what you have to do is you have to find out the mean, that is a plus b by 2. Then once the mean is known, then you can evaluate fa times fxm. If that value comes out to be less than 0, then root will be there, or I mean to say that root will be lying between a and xm. So the outer limit b will now be xm, if this thing is true. Otherwise, if this is false, then a will become xm, and the reason I have already discussed in the previous lecture. Okay, now once this has been done, then you do what? Then you repeat the process. Till what point? Till the absolute value of the function at the mean is less than 10 to the power minus 3. That means you are very close to the root. So if you take this problem, for this problem between -2 and 2, you should get 1. And let's say if I take 2 and 5, then what you should get? You should get 4. So let us write the program first, and then we will take different problems. Okay. Now first we should have one function. So let us say this is the function, and it is x square minus, I think it is 5x plus 4. Yes, x square minus 5x plus 4 is the function. Now inside the main, what I should have the bracket. Okay, double a, and it is -2, and b, it is also, no, it is 2. Okay, once this is known to us, then we will be checking the condition that if f a times f b is less than 0. If this is less than 0, that means root must be there in between a and b. Okay, then we have to do all the work which I have discussed here, this work. If it is not 0, then you have to stop. So let us write the stopping criteria first. Else, what you have to do? You have to simply say the root is not present in the interval. What is the interval? It is a, and then comma, and then this should be, this should be closed, and then b, and then close it, and L. Okay, so if fa times fb is not negative, then root are not there in the interval and you come out of the program. That's it. If it is there, if the root exists, then you have to find out the mean. So let us declare one variable xm, and this is the average of these two values. Once this is done, you have to check first that is fxm, the magnitude of it is close to 0. So if the absolute value of f at xm is less than, let's say, some epsilon. What is that epsilon? We have to define it. So let us define it here. Const double epsilon, and let's say this is nothing but 10 to the power minus 5. Okay. So now if the absolute value of the function at the mean is less than epsilon, then you already have your answer. So what is the answer? Root is equal to xm. Okay, and then you come out of this particular loop. Where is the loop? Oh, we have not done anything. Why? Now this all should be repeated so many times, then you should have some loop here. So while, make one infinite loop, while true, then do what? And do whatsoever you are writing here inside this loop. Okay, so we have to repeat it many times. We can only break out of this once the condition is met. So break. Okay, let's say this condition becomes false, then I have to check again. Else if the product of fa and fxm is less than 0, that means now my root will be lying between a and xm. So the left limit will be a, right limit will become xm. So in place of b, what I will be writing? Xm. And if this is also not there, then certainly fa times fxm must be more than 0. Then in that case, what I have to do? I have to take a as xm. Sorry, xm as a. That means I have to change the limits. That's it. It is very simple. And the program is already done. So now you have your bisection method ready. Okay. So now if I run it, I will be getting root as 1. This was expected because in a bracket of minus 2 and 2, what I should get? 1. So if I take the bracket, if I change the bracket from minus 1 to 1 to 2 to let's say 5, this is my bracket, then the root should be 4. Okay, so let us, before that, what we will do is we will write one more thing. We will create an integer counter and initialize it with 1. So once this iteration is over, I should do what? I should first print the counter iteration number, and that is equal to count count and ndl, and then increase this counter by 1, so that I can also know that how many iterations the program has taken. Okay, so yeah, so if you run it, oh, it is already running. So if you run it now, so it has only taken 1 iteration. Basically, it must have taken more than 1, that is 2 iterations. But in this case, it is only doing it in 1 case, 1 go. So if you increase it from minus 2, minus 2 to let's say minus 10, then it has, oh, it is not updating. Why it is not updating? Why? Oh, I have kept it wrong. Sorry. This should, no, this is correct one. Control Z. Why it is not happening? If this, else you do this, else you do this, and then you increase the counter, and this all is happening in the while loop. Yes, this is the wrong place of inserting this one, because it will every time do what? It will make this counter 1. So if you let us do again from -2 to 2, so it is taking 1. Okay, so if I increase the counter from if the bracket from -2 to, let's say, -10, then it has taken 20 iterations to arrive at this answer. So if I make it, let's say, 100, then 22 iterations this has taken to converge at that particular answer. Okay, so in this way this program works. Now what we'll do is we will change the limit from -2 to 2 it was previously. Now we will change the limit from 2 to 5. Okay, so what we'll do is the left limit is 2 and the right limit is 5. What is expected? Expected is that I should get 4 as the answer. So let us run it and see what happens. So now you have root 4, and how many iterations it has taken? 18 iterations it has taken to come at the converse solution. So friends, in this way you can write your C++ program for bisection method. One more thing, that this particular program has taken too long to converge. So what is the better option? The better option is the one which is called as Newton-Raphson. It is a very fast method, and if the function is very nice, so it can converge in very less number of iterations because it works on tangents. So we'll see it in the next lecture. In this lecture, till this point only. Thank you very much for watching it.